Hello and welcome to Sean White's Solar and Energy Storage Podcast.
So today on the show, we have Steve Feinberg, and Steve is president of Blue Water Battery Logistics. I'm a sailor, and to me, blue water means going out where you are far away from the coast. So what does blue water mean to you, Steve Feinberg, president?
Oh, thank you, Sean. Blue water actually does mean the ocean, and yours truly actually sailed around the world when he was 19, and
Wow.
some of the other owners have actually done a lot of sailing with me, and that's partly where we got the name.
Did you see like any pirates out there?
When we were near Somalia, we were pretty scared. We had reports there were pirates, and we had hit a big storm, and it had thrown us almost 100 miles off course. And we were getting close to where they were pirates, but we never saw any.
Wow.
We had shotguns on board to protect ourselves.
Okay, yeah, I'm sure that would have worked.
I wasn't a very good shot. Let's just say the pirates would have been safe around me.
Yeah. I know, I can't never figure out why with those big old huge ships and then some little skiff robs it. You'd think those guys with a big ship could have some pretty big guns on there to take those guys out. But yeah, and then other things that I was thinking about with blue water is there's saltwater batteries and sodium batteries, and there's a way to make electricity by fresh water and salt water, and then as it mixes, it kind of works like a battery, and they're working with that too. So there's all kinds of neat things.
Yeah, they're making batteries out of everything. They make them out of aluminum, they make them out of sodium, they're making out of iron, all sorts of different elements. But primarily the big one now for energy storage, the lion's share is what they call LFP, which is lithium iron phosphate. That's by far for the big utilities. That's what they're using.
Yeah.
It's probably 90% of the batteries for utility scale.
Yeah. Do you think, any idea, what do you think, is that going to change in the next few decades? There's people that talking about doing things different ways, or just, I think even with solar, there was crystalline silicon was around since the 1950s, and the whole time there's always people going like, this is going to change everything, and pretty much it's crystalline silicon. So is that going to be the same way as lithium ion batteries are just going to be the way and everything else is just noise, or is there hope for some of these other technologies?
So I'm going to give you a little roundabout answer. My background is in computers, telecom, and now in this industry. And computers started, they were the size of a room. By the time I exited the industry, you had laptop computers, and they'd make them smaller if they could. And they were cost a lot less. Telecom was the same thing. A cell site was $1 million. They were down to $10,000 or less. And I see the same thing happening in this industry. A 1 meg battery container was 40 feet long. Now they get 11 megs in a 20-foot container, and the prices of batteries are dropping. And one company recently announced that they're going to come out with their first sodium battery. So there's going to be a lot of changes. I think we're going to find the batteries, the price is going to come down. I think we're going to find that they're going to get smaller and smaller and smaller, which is good for the consumer.
So yeah, and so what's the angle with blue water? So battery logistics?
Well, our company is unique. We started off, the plan was just we were going to be picking up batteries from utility scale companies when they decommissioned them and bring them to recycling centers. We were also going to do that with EV car batteries, truck batteries. And we started getting asked, hey, can you help us move our new batteries? And then we got asked, hey, can you help us move our solar panels? And then can you move our this and that? And so now we've kind of changed our services really to the point where what we do is we take care of companies, we jokingly call it dirty laundry. Anything that's surplus they have, it could be new surplus batteries, solar panels, transformers, it could be equipment that needs to be recycled. We find homes for it, whether it's recycle or a reuse value to it.
Okay. So you're not just working with batteries, you're working with transformers and PV modules and the whole thing?
We do hundreds of thousands of new surplus solar panels every year, hundreds of thousands of used solar panels. We do transformers. The biggest one so far is 193 MVA we found a home for. We've done truckloads of battery cells. We're bidding actively on 35,000 modules that were in an energy storage fire. So we do lots and lots of different things, inverters that are used to charge the equipment, many different things.
So when you're recycling or, taking care of these PV modules, battery modules, are they getting reused or are they getting, crushed up and turned back into stuff?
Every opportunity or every situation is unique. Sometimes a battery is just simply picked up and ground up for the metal value. Sometimes we pick it up and because it's LFP, which doesn't have very much value to it, it's a charge. And sometimes it could be an LFP battery that has not been used very much, and it'll have a reuse value, and it could be turned into, the cells are taken out and then they're made into either flashlight batteries or they could be made into drill pack motors or something like that. Mm-hmm. So each opportunity is unique. No one can I tell you 100% this is what's going to happen until we do some research on it.
So when you get a battery, like NMC is the one that they use in the long-range cars and they used to use for stationary energy storage sometimes, not so much now. And then there's LFP, the one that we're seeing in all the energy storage systems and some cars that don't go as far perhaps. And when somebody has some of these batteries, you said the LFP isn't as valuable. So like when somebody has the batteries, are you looking at the recycling value? Like, is there much of a recycling value at all for the LFP, or do they have to pay you to recycle it, or is it something that you would pay for, or maybe with the LFP and the NMC?
That's a good question. What we try to do is the most environmentally and economic solution. Okay, it's much both economic and environmentally friendly to find a reuse value for a product or for batteries. So if we can find a reuse value, we go that.
Sure.
Both because it's better for the environment, but also we tend to, we can make more money doing it that way. So it's good. So our suppliers or the owner of the older batteries, they can actually save some money using us, but also they're doing a more environmentally friendly solution. And each situation depends on that.
Yeah. So like, let's just say that somebody has a bunch of old LFP batteries that there's no value left because they're totally dead. Maybe they were in a 2011 Nissan Leaf. I have one of those. And it still works, but nobody's going to take the old cells and put them into another car. So you have to take them, crush them up, get the different components out of it. Is it worth it? Is there like money in it?
So let me come back to you on that one. Mm-hmm. I'm going to challenge you that old battery may or may not have a value. There are companies out there, they do take batteries like what you have, and what they'll do is not all the cells are bad. They don't go bad at the same time. Some of them go bad and others are fine. So there are companies out there, they would buy that Nissan Leaf battery, and they'll take 3 or 4 good cells out, and they'll use it to rebuild other Nissan Leaf batteries, or it could be a Prius battery, or now the companies are doing Tesla batteries. So those companies, once they're done with it, the stuff they have really is bad, and that is a charge, and it's anywhere from $2 or more per pound to have it recycled.
So you have to pay $2 a pound to have somebody recycle it.
That's right.
And then I guess there's probably also people that just say, well, I'm just going to throw it away and then put it in the landfill. It's not really toxic, right? I mean, lithium, iron, phosphorus. I'm not saying that people should do that, but I assume maybe they are.
Yeah, I mean, but also it's like, it's my running joke. You don't want to take a battery and throw it in the ocean because you'll get arrested for salting battery, right? So, it's a dad joke.
It's a good ballast for your blue water sailboat.
Yeah, well, we actually have a real anchor there. We don't need the. So I don't know the statistics, the exact statistics. I would say this: energy storage batteries tend to much more be recycled. The ones where there's more of a problem are the consumer electronic batteries, that they get thrown into the trash and end up making landfills because it's so difficult to get them sorted out. So forth. I think there's a much higher percentage of that goes into landfills. Talk to the waste management companies, literally waste management They have lots of fires in their trucks that start from these batteries that consumers just throw in and they get fired.
So I think some of these batteries, just like I was thinking car batteries, but it still goes for stationary energy storage systems, they're kind of heavy. And so if you had a car, it's probably like thousands of pounds, the battery. And so you're talking like double of that, thousands of dollars.
Could be very expensive, yeah. But again, let's go back. Some of these batteries do have a reuse value.
Mm-hmm.
You have a used Tesla battery, for example, or Prius battery, or Leaf battery that you just described. There are rebuild centers around the United States. They're interested in those.
Yeah.
They'll take them and they may pick it up for free. They may charge you a very small fee for taking it away. And they'll take the good cells out and then they'll reuse it.
Yeah, do they even do that? Like, say that you have a car and there's a battery module goes bad. So you take it into the shop and then the manufacturer pulls out that bad module and they swap it with a pack of refurbished cells that came out of essentially another pack where they just took the good cells out of it.
Yeah, they're not at that level, but the refurb shops, what they usually do, they'll have a complete battery ready to go.
Mm-hmm.
They'll have you bring it in and they'll have to go through the entire battery. So you may have to leave your car there for 2 days or it could be a week,
Mm-hmm.
and they'll swap it out. But they're not at the cell level to do it. They like to be the quick in and out swap of the module.
I got a 2002 Prius in 2002, and people would stand around and go, wow, look at that modern marvel. And I said, my next car is going to be electric. And trying to think about 5 or 6 years ago, I got an electric car. So I had that Prius from when it was a modern marvel to where people were just like, when are you going to get rid of that piece of junk? And that outdated piece of junk. And so I went through 2 batteries. The first battery that I went through, I took it to this guy and he was up and, I had to drive an hour to get there. And what he did is he just took old batteries like from junkyards and things, cars that got in accidents, and he tested every cell. He put a load on it and tested the voltage.
Exactly what I'm saying. Yep.
So it's called a load test. And then he put all the good cells in a module, and then he took my battery out and he said, I'm going to take your battery, I'm going to load test all the cells, I'm going to take all the bad ones, get rid of them, and the good ones, they're going to go in somebody else's car. And so I thought that was pretty neat what he was doing.
Yeah, the Priuses, they call nickel metal hydride. So
the old ones, yeah. Uh-huh.
Yeah. So what he would actually do, and those actually, because they have a lot of nickel in it, they actually have a good value.
Oh.
The bad cells actually, he would get money for the bad cells. Some of these companies do thousands of these batteries a year, and they have tens of thousands of pounds of bad cells, but they get money for it from the recycling centers before they grind it up to turn it into, reuse to get the metal value out of it.
Yeah, I've heard that, speaking of nickel, that's 5 cents. If you melt it down, it's worth 10 cents. So we should just, double our money that way.
That's why they eliminated the penny, because it costs 3 cents to make a penny.
Uh-huh. And I'm sure the metal's got to be worth more than a penny just if you melt it. Yeah.
At least 3 cents just for the metal.
Yeah. That's crazy.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
So what about the cobalt? So we have the NMC, lithium, nickel, manganese, cobalt oxide, and cobalt's kind of the one that's a big deal. It's a conflict material. It goes in the cars, especially that have the longer range. It's the type of battery that you don't want a full charge all the time. It's a little bit more sensitive. It's the one that's in all of our phones. And so that's more valuable, especially since people want to be like conflict free and they don't want to go to the Congo and get, have children mining for battery for cobalt for their fancy cars and stuff like that.
Yeah, you're right about that.
So as far as like a recycling value, so like let's say what is the recycling value? Like 85 kilowatt hour car and it got in an accident. What's the recycling value of that battery? Like, I mean, it still works, but if somebody just grinded it up.
The value of the battery is not necessarily the metal value. The value of the battery is the cells for the guy that rebuild it.
So what would somebody do with a bunch of old 2015 Tesla batteries?
What they'll do is they'll take the cells out, and it allows them to rebuild other Tesla batteries. Let's say they get $3,000 or $4,000 to rebuild the Tesla battery, and then let's say they could buy a used battery for $1,000, which is probably where it would be, somewhere in that range. Or even they would just pick it up for free, something like that. And they would get enough parts out of it to rebuild anywhere from 1 to 5 other Tesla batteries. That's what happens.
Yeah. And so let's say that the bad cells, like there might be a small percentage of the cells that are not worth reusing. With the ones with cobalt in them, are they worth getting the metals out of it?
Yeah, that part then usually anywhere from 10 to 20 cents a pound.
So then you get money.
Right, the recyclers would give you anywhere from 10 to 20 cents a pound. If you have volume, you can't just bring, a few cells there, they won't pay you. But, if you bring a truckload at a time.
Maybe those guys that were ripping off catalytic converters, they can start going after the batteries now.
That's true. I mean, let's face it, there's guys that go under the big statues from places that get the bronze and the copper and all that stuff.
Yeah.
The worst ones are the guys that go and they try to steal the transformers. They don't realize there's high voltage, and unfortunately they find out.
Yeah, that's a good thing about Darwinism. Sometimes it takes care of that.
Yeah, right.
So some of the things that you're dealing with are like finding homes for brand new stuff that they've just bought too much for a project or project didn't go through, something like that, and then also used?
That's correct. So a project could get canceled. If they're doing a solar farm with 2 million panels, let's say, they don't just buy exactly 2 million. They want to have some extras because they know there's going to be breakage and so forth. So they buy extra, and then they look at the project's done and they don't need it anymore and they sell it off.
And those new ones, they probably still have the warranty and all that. And so where do you sell them? Do you sell them to distributors, to people building projects?
Actually, no. Most of our business is to support the older equipment. Let's say somebody has panels that were made 5, 6 years ago, 10 years ago. They're more valuable to the people that have existing solar farms or commercial because the newer panels are higher wattage. They're not compatible.
Okay, so I think they call that repowering.
They call it repowering, yeah.
Okay, so they repower a system. They take off the modules that are 10 or 20 years old. They put on brand new ones, which are probably a different size.
No, the ones we sell, we panel match it.
Oh.
That's the service we have. We find something that matches the size.
That might be difficult to find new ones that are the same size just because they're getting so big.
Well, we're finding surplus. We find new surplus that's 6, 10 years old.
Oh, you're finding like stuff that's been sitting in the warehouse for a long time. Okay.
Yeah, with that bread.
So that's very convenient for some people.
Well, it helps the people who are sitting on it to get a return on.
But if it's old stuff, then it's not as efficient as the new PV modules because the degradation isn't huge, I don't think.
Well, no, the stuff that we have is new surplus sitting there in a warehouse, so it's fine. It's new surplus.
Yeah.
Just like buying.
Okay, so you repower a system. So you take the old ones off, you put new ones on. What do you do with the old ones?
Good question. One of two things happens to them. Depends on the condition of it and the situation. Sometimes there could be a reuse, and they will go to a company that international, or they can go to a company and what they do is they remanufacture them. They'll take them and clean them up and remanufacture them so they'll get another second buy in the U.S. Or they could get shipped off internationally to Africa or someplace, or they just get scrapped. They just get recycled.
So you said remanufacture. What do you mean by that?
They take the panel. There's different reasons that the panel degrades. It could be a layer of dirt on it that could never be cleaned off by normal methods. The connections are no longer that good, so it loses some power because of bad connections.
But those sound like things that could have been fixed in the field.
No, it's hard to do something like that. The connectors are underneath the
Hmm.
panel. You have to take the panel off anyway. And besides, you want to do things efficiently. You want to just take it off, put the new one on. You don't want to get involved with having
Yeah.
your guys are cleaning up, and you may or may not be able to fix them. Better to do it in a factory manner.
So you remanufacture them, and then you might put them on some system that had older modules on it, and then what do you do with those older ones? They could just get like all along down the line.
Somewhere along, let's just say this, anything that's ever installed in the United States or the world, actually, there's a possibility that we could touch it and figure out a solution for it. The solution could be eventually it gets ground up, and the solution could be that it gets a reuse. It will be one or the other.
And so also like PV modules, a lot of people think like, oh, we got to recycle them. They think they're going to be toxic. They're not really toxic, right? I mean, First Solar's got cadmium.
Well, there's one company called First Solar, and their modules have cadmium in it. That's pretty toxic.
And they have their own recycling program for those.
They have their own recycling program in Europe.
Yeah.
But most of the other stuff, believe it or not, the EPA says you can take it, grind it up, just throw it right in the landfill, it's fine. We don't think of that as recycling. We don't do that. We think of true recycling as, you grind something up in whatever process you have, then you find a use for it. So with solar panels, it could be you take the layer of the solar cells off. What's left is ground up, and it could be mixed in with cement, landfill. It could be used for glass products. But that's what we consider true recycling. Somehow how you use it, find a use for the stuff and not just throw it in the landfill. We just don't throw anything in the landfill, which is part of our policy.
Well, that's good policy. Yeah.
But, well, we're good at finding reuse for things
No,
too.
I think that's great. I put all recycled PV on my mom's house. She's got a whole bunch, every different direction, facing every azimuth there is. And I think people are kind of too eager to take a PV system that's working perfectly well, making great sine waves, and change it. And then they change their interconnection and all that kind of stuff.
In addition to this podcast being brought to you by Sean White's Solar and Energy Storage Podcast, it is brought to you by water. Take a sip and just think, where would you be without water?
Well, let me explain to you what our business is. Picture a solar farm, right? What goes into the solar farm? There's tons of wires, there's metal that hold the panels and stuff. But the farm is working, it's making electricity, it's doing great. If you were to replace all of those panels and put new panels in, it's actually more work than starting from scratch, because now you have to pull out all the wiring, you have to pull out all the metal that's been put in with pile drivers and so forth. And it's not that simple. It's simpler just to keep what you have there working and being used until there eventually will come a time when it gets too old and you have to pull it out. But if you're able to keep it going longer, what actually can happen is you can leapfrog a generation of panels. So let's say the current panels now, let's just throw it out. Your original farm was 300 watts, and you could put in 500 to 700 watt panels now. But there's a new generation that's probably going to come out in 3 years, and it's going to be 1100 watt. And if you could leapfrog the 700 and go to 1100 watt, wow, same space, and you've got a lot more power in the same size. So there is an advantage keeping your project going longer and leapfrogging for the next generation.
I know that the increase in the wattage of the modules has a lot to do with the larger modules rather than the efficiency. So maybe you would take some modules that were portrait, and then when the next group of modules are going to be landscape, and they'll have like the one is the same as the length of the other.
So then what's going to happen on the next generation? The next generation is going from like 23% efficiency up to 32% efficiency. It's a whole new design, and so it's going to be a lot more. It's going to be a different. It's not just making the module bigger to do it, or actually going to bifacial where you get the extra power from the bottom. No, this is a whole new.
Well, that's pretty efficient if we get there. I know they could do, get up in the 30s for space solar, but that's just so expensive to do that.
Well, technology, I mean, I mean, I remember when I had a computer and it was at 386 and I thought it was the greatest thing in the world. And look where we are right now. My cell phone's way more powerful than that thing ever
Yeah, I
was.
know. Huh?
Years ago, it just scientists, they're smart. They try different things. There's new metals and chemicals. And
I guess I also think too, though, that you have a functioning solar farm, and it's like, it went from the efficiency. Let's just say that it did increase 50%, which I don't think that's going to be too common. The efficiency increasing like 50% or something like that. But even if it did, is it worth it to take it down if it's working, or you put another one somewhere else with that same money?
well, my career has been wrestling with these issues all the time in computers and then telecom. And probably like in telecom, let's use an example. They would have a pipeline, right? Well, for cellular service, you need to put in better and better things, more bells and whistles. You're going to have videos and pictures, texting, and all that. But a pipeline, meaning oil and gas pipeline, once you put in your telecommunications equipment, that's all you ever need. You don't need to change it out until you can't maintain it anymore. And so typically in that industry, we would see telecom that was anywhere from 15 to 30 plus years being used. And I think it's going to be the same thing in this industry. Once the panels get so old and you're not able to maintain it anymore, and the inverters you can't get parts, and the panels are finally falling apart. Now it's time to replace it. That's when you do it.
You know what I got that was kind of interesting about, I don't know, a year ago or something like that, was I found on eBay Arco solar modules from the 80s, brand new in the box. And I had my friend Jeff Spees came up. What was that?
What were they, 30 watts or something?
Something like that. I think it was a little bit more than 30, but I don't even think it said, it didn't even have the sticker on it, I don't think. But it looked like a brand new solar module. It was weird looking compared to what today's modules are, but it looked like brand new, because I have an old used one that's the same size, and it's like, it's kind of had some browning and photo degradation of the encapsulant and stuff. It still works great, and it's from the 80s. But these ones, it was just like brand new in the box. It's pretty neat. So I'm going to put them up on my wall. I'm in the process of making a solar training center, and I'm working on even getting some, equipment to put there. I want to make like a little standalone grid with AC and DC coupling, and I'm getting a electric vehicle that I can power that little standalone grid with. And it's kind of amazing too, like how much energy storage is in a car. I found right now they have a Silverado pickup truck that has a 205 kilowatt hour battery that I test drove, and it's got like a 450 mile range. It's kind of crazy. I'm tempted to get it. But then I'd have to use the proprietary General Motors equipment to connect it to a grid. So those are some of the things I've been thinking of just recently.
I have a Tesla Equinox, 2 electric cars. So.
Oh, yeah. Great. Yeah, and its problem with the Tesla is right now, there's no way they're going to let you export it to the grid. One workaround, though, is some of the trucks, like the Ford F-150, the Silverado, the Cybertruck, is they have a 240 volt outlet. And so you could hook that up to a battery charger, charge a battery, and then hook that battery up to the grid. It's kind of a workaround. The Ford F-150 pickup, I'm actually probably going to get that one. And you can hook it up. They kind of opened it up a little bit, so there's different ways that you can connect it. And so you can take it and you can hook it up. I think it's called SIG Energy, and then you can make it go EV to grid. And then the Rivian is just using the ISO standard. So the Rivian, as soon as they make the charger, it's going to work, even the ones that they made in 2022. So if my research is right, I have to disclaimer. But yeah, if anybody out there knows, let me know about how to connect some of these cars to the grid. I'd love to talk to people that are up on all that. Everybody's got something that says it's going to work tomorrow, but not today. We're almost there. And the wall box, I think, only works in Europe right now, so I need a 50 hertz grid. And So yeah, well, it's been great talking to you, Steve Feinberg, president at Blue Water Battery Logistics, who's also doing logistics for solar modules and transformers and all kinds of neat stuff. And looks like you're in Santa Barbara, I guess?
I'm personally in Santa Barbara. Our headquarters is Los Angeles. We have approximately 27 employees now, and we're going to be adding another 20 is our plan. And we'll need the extra help as the sites get older and the heat.
So you're looking for workers?
We're looking for people.
Okay, I have some people for you.
Yeah, send them our way.
Mostly in the Southern California area?
We would prefer them to be either in Santa Barbara or in Los Angeles.
Well, Santa Barbara is a beautiful place. I'm sure everybody wants to move there.
It's really rough, and somebody's got to live here. So, I put up with it. But it's tough. Good weather, 330 days out of the year.
Great.
Having an ocean right nearby, places to hike, bike paths.
I know, tough.
Well, no traffic. I don't know how I'm going to survive.
I think I'm going to come down there and get a job from you. All right. Well, anything to finish off with, or want to tell people where to find you?
BlueWaterBattery.com. That's our website. Email me at Feinberg at BlueWaterBattery.com.
All right. Okay. And then speaking of, do you have a blue water sailboat, or do you have a sailboat?
I share a boat with some friends.
What kind of boat?
Sadly, we're going to probably be selling it this year.
What kind of sailboat is it?
It's a big boat. It's a Perini Navy. It's like 170 feet.
Whoa, 170 feet.
Big boat. I have a lot of friends.
That's bigger than a big boat, I think. All right,
Yeah, well, there's a lot of friends that have, like I said, I sailed around the world.
Yeah, but 170 feet. I don't know where you would keep that.
I keep in touch with the guys, and the guys have families, and the families go out. We chip in. It's kind of a big project.
Well, I hope you have some of your blue water batteries on that blue water sailboat.
Nope, it's a sailboat, lead acid.
Okay, all right. Well, good. Well, thanks a lot, Steve Feinberg.
Okay, nice chatting with you.
All right. Yeah, if you want to do it again sometime, just let me know.
Yeah, we can do it again.
Okay. All right. Well, thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, go to SolarSEAN.com. And if you want to get your energy storage installation professional NABCEP certification, go to SolarSEAN.com/ESIP. That's the ESIP, the best energy storage exam that's got the best knowledge and the best way for you to learn and get all of this great knowledge. And then you can go down to Blue Water Battery Logistics and get a great job.